Alright, today on the laboratory we're going to do something separate from the standard repairs. I'm going to make this crystal light up. There's a fellow YouTuber who goes by BigClive. He has this print file on his video. We did the print file, but we scaled it down a little bit so it's slightly smaller than what he had. But it's the same shape. And I got some RGB LEDs that will rotate through the colors, and to make the 7 crystal spikes light up. I'm going to make it run on USB, so it's going to run on a 5-volt supply. In advance, I cut the end off and separated the two wires. The black and the red are the hot and the negative. There was a green and a white wire which I already cut off. This cable, the end here was smashed, so this end's still good, and this end will plug into a battery pack or any USB power supply for your wall socket for your cell phone. What I did to the crystal in advance was I trimmed off some of the plastic that was sticking out, and I had to make this hole that's already here slightly larger to fit the cable. So just to give you an idea of what it's going to look like, let me turn on a little bit of power here so you can see what the LEDs are. They self-rotate. So I don't have to add any circuitry to it. I just have to give them power. So it just goes through the different colors. These run at 3 volts, so I have my power supply set at 3 volts right now. To run them at 5 volts, I'm going to have to run a resistor, which is right there. I'm going to run 100 ohm, it should do, based on using the Ohm's Law calculator. And of course, if it's wrong, LEDs will be overdriven and burn out or really dim. The holes fit the LEDs, but they don't fit snug, and that's nothing to do with the file. That has to do with the scaling that we did, because I had to clean up the holes to get the residue out from the 3D print. So I'm going to put a dab of hot glue on them as I stick them into their respective spots. All the LEDs are going to be wired in parallel. Because if I wired a couple in series, the problem I would have is they run at 3 volts each, and a battery pack only puts out 5. So we get a little too dim for my liking. Never hot glued to 3D printed plastic before, so we'll see how it works. As long as I don't burn myself. And any of the extra glue, since it's hot glue, I can just peel it off so you don't see it through the opaque plastic and get all these strings. If you download this file and print one yourself, I'd recommend that if you are going to put a dab of glue that you do the center one first, because that would have made a lot more sense. The LEDs I got off of eBay. You get like 100 pack for a few bucks. And we're actually printing another one of these using glow-in-the-dark plastic, which we'll probably put UV lights in so we can supercharge it. And it's actually at full size, so it's not scaled down. We were trying to scale this one down for the smaller LEDs, except the holes were still a hair too big. That's fine. So, there we go. Make sure the hot glue gun's not touching anything so it can cool down. And get some of the hot glue off crystal. When I watched his video on how he made these, it reminded me of the Dark Crystal movie. If I had some purple 3D print stuff, I'd make it glow, but that's why we're going to use the UV lights on the next one. So. Get a couple of pieces of scrap wire. And we're probably going to need some heat shrink so we don't short out the hot and the ground. I'll use a piece of white so it kind of blends in through the opaque. Everything I do has to be recessed below this lip so it can still sit flush on the counter or table. So what I'm doing now is I'm getting my leads together while the soldering iron warms up so I can solder these and then cut off the excess. You could technically cut the excess off in advance. Probably make it faster. That's not a soldering gun. This will take just a few moments. Normally I'd also recommend testing these lights in advance. Chinese LED, actually that was still warm. Chinese LEDs, sometimes they don't all work. I didn't test all 7, I only tested 3 of them. So there's a good chance that when it gets turned on I might have a couple that don't work. But it is what it is. Cut off the excess here. Now we just need to solder the center one. Let's see which one's going to line up the best. That one should, right there. one over. So if I did this right, I should have the positives to the positives and the negatives to the negatives. What I should have done was actually marked them, because, you know, common sense, but yeah. Nope, that one works. That one works. Yay. Wired right. Now, before you solder any of the wires together, you should definitely make sure you feed it through the hole. Now I drew this hole out so it's not super loose, but not super tight, so I can feed the wire back and forth. And then I can put a dab of either hot glue on the inside as a strain relief, or I can put a zip tie. Zip tie it really tight around the insulation. It's very common. I see it all the time in my industry. On all the low voltage wires, they put a zip tie right around the sheathing so you can't pull it back out. Just get the hot glue gun out of the way. We pre-tin some wires. I would normally be doing Limax, but I just have a time constraint today, so I figured I'd do something independent from Limax for the moment. Also, I'm waiting on some parts. I have a Department 56 and an Enesco music box that they both have the exact same motor, and both of them have the exact same problem at the point that I'm at, where they both have a burned out motor. And some of these hobby motors are hard to find, especially since both pieces are older pieces and they've changed the way they build them since then. Now I have put the resistor on the hot side. A little too long. Of course, if you find the soldering and stuff boring, you can always skip to the end when it's done. Yeah, it didn't work. I almost made the mistake of soldering it without putting the heat shrink on. That would have been, well, typical. Alright, now we just need to get all the hots together and then all the grounds together, and we'll be good to go. some of the extra pieces out. Alright, now we have all the grounds tied together. Now we just need to attach the incoming ground wire to it. So, I know it's hard to see because it's such a small project and the distance to the camera. So right now I should have one light. Oh, never mind, I got 3. Now we just need to connect all the hots together without them touching the grounds. I have the wire just in case I have to do a jumper go across, but I think I have the spacing right to where I can attach them where they don't touch each other. Then the worst case is I can fill this with hot glue to act as an insulator. Since the hot glue, when it dries, is almost the same color as this plastic. That's one. 2. I missed a... Get out of there. And, oh, did one wrong there. Which one did I do wrong? Hot, 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 ground, ground, ground. Negative. Use my machine because my machine will detect a short. I'm sure that's what I just did. Let's see. Negative. No, no short, but I do have one light that doesn't work. So why doesn't this light work? So I have a bad LED. And that's why you should test them in advance. I didn't test it, and now I have one that doesn't light up. So, and that's probably why the battery pack doesn't work. I've now separated that LED from the circuit. Yep. Yeah, this LED is at 3 volts, is pulling 1/2 amp and it's not lighting up. So yeah, I got a bad light. I got to desolder and unglue. Awesome. So that's what it looks like. The battery pack keep turning off. I don't think this draws enough power for this battery pack. This battery pack has a load sensitivity. Yeah, I don't have enough load on it. Let me try plugging it into that. This, I just plugged it into my power supply. My power supply does not have a load sensitivity, meaning that if it draws less than a certain amperage, it won't turn off. But this is what it looks like as it sits. I'm going to turn off another set of lights. Now they won't rotate in sequence, which was part of the point, so that's why you'll start to see different colors forming. What I'm doing is I'm grabbing another LED to replace the one that shorted out. Grabbed the wrong package. Normally when I buy LEDs I try to test them all. Like I said, I only tested 3 of the 7. Apparently one of them is bad. The reason I know it's bad is when I actually send power to it, the LED is passing a 1/2 amp of current at 3 volts. It's well above what an LED should handle. And if I reverse the polarity, it passes amperage too, which an LED shouldn't do that in reverse unless you overpower it. So as you can tell, we're now starting to go out of phase, which actually looks pretty good. The camera, I can't tell how good it is on the viewfinder, but it actually looks pretty neat in person. Anytime you start and restart power, it will of course rephase together at red, which is the first color, and slowly work its way through. So I'm going to go ahead and break the glue, solder in a new LED, and then come back. Since I should have done that before, and I don't want to waste your time for the next couple of minutes while I do this real fast. So I got to reheat up the glue gun. And then we'll let it play through all its colors and see how far out of phase it goes. So, shall return in just a few. Okay, we're back. You can't tell, but this LED, when you look through it from the side, is black. It definitely smoked itself. So, there it is on, with all 6 legs working. And then the center, of course. Not sure how or why it burnt, but can't pass a 1/2 amp through an LED. Not a single one like that. So, desoldered it, resoldered it, and there it be. There is the BigClive crystal done here at the house at a slightly smaller scale than what his print file was, with RGB LEDs that independently will cycle from themselves to give you a depth of color. The next one I'm going to do is going to be glow in the dark. It's not going to be today. I don't even have it yet. It's still, well, it was just cured yesterday. So, and this is a good example of why you should probably test your lights before you use them. Like I said, I only spot checked them. Apparently I didn't spot check the right ones. And I'll give you a idea of the back, how I kind of did the soldering. The light might be a little intense. Let's see if I can change the color range. Maybe, there we go. Helps a little. And then we'll unplug it. Basically, they're just elevated. All the negatives are together, all the positives are together right off of the incoming power. Put hot glue around it so it can't be pulled through or pushed in. I will have to tell you that I've never hot glued this stuff before, and it's hard to peel off. It really likes to stick to the pores. I was surprised. I'm probably gonna, since you really can't see through it, even with all those lights, when you look at it from the outside, I'll probably just pot this in hot glue, or at least hot glue all the connections. They don't touch anything, so when it sits flat, there's no problems. But that's it, and I'll heat up to heat shrink. I didn't heat it up yet to make it adhere to the resistor. So it is 7 RGB LEDs, slow rotate, the straw hat style, sorry. One 100 ohm resistor, 5 volt power supply. I did look it up. This is a Duracell brand battery charger, and it does have a load. So if there's no load detected, it turns back off. This, when I hook it up to my bench power supply over here, this is plugged into, it literally is registering 0.01 amps. So we're talking so minute that this regulated battery pack will only let it run for a moment before it turns itself back off. So I could put another resistor in it across from the hot to ground or negative to positive to increase the load. I'm not going to do that. Honestly, when I stick this up on my shelving, I'll just have this plugged into a very cheap 120 volt 5 volt cell phone charger from the old days. It only puts out like 180 milliamps, I believe, so it's a really cheap one. And I'll just have this sitting on my shelf, and when I flip on the light switch that turns on that wall socket, it'll start to glow. So thanks to BigClive for the file, so I can make myself a lighted crystal. The next one will be slightly larger, and it will be glow in the dark. So we'll see how that one turns out. That'll be a little bit while from now. I'll plug it back in so you can see it in its full lit glory. And as usual, thanks for watching. We will be back to the standard Lemax, Department 56, etc. type repairs. I just didn't have much more than about a half an hour of time today to do something, so I figured I'd sit down and do this and show you that you can do things with RGB LEDs, and you can look around for print files if you have a 3D printer or know somebody that does, and you might be able to do some RGB LED print files. And you can make solid colors too. I just wanted to try the RGB because I know they're going to go out of sync, and I like the way it looks. So, all right. Thanks for watching. Till the next one.